So we started the note sheet yesterday, and I believe we finished up with this problem here, was the last one we covered. So the next theorem we're looking at is segment of secants and tangents theorem. If a secant and a tangent segment share an endpoint outside a circle, then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent. So the tangent times itself is going to equal the outside times the whole of the secant. So if we have a tangent segment and a secant segment, the tangent times itself will equal the exterior times the whole length. Now if we look at this in one of the problems, we have this here. We want to find RS, the segment outside. Now what we're told is the tangent segment squared, so RQ squared, is equal to the exterior, RS, times RT, the whole. Tangent squared is equal to the exterior times the whole. So for this here, RQ is 10 squared. RS is X, and the whole length would be 15 plus X. We would indeed. (15x plus x squared). Well, we can actually do 10 squared. 10 squared is 100, is equal to x squared plus 15x. Now at this point here, we want to get this equal to 0. So we would minus 100 from both sides, telling us that 0 is equal to x squared plus 15x minus 100. Now for these here, we do need to factor to be able to get the solution. Now it's been a minute since y'all actually did factoring, because you did these in Algebra 1, but y'all did them at the end of the year. Now whenever we factor, and we'll go over this again, especially in Algebra 2, if the third number is negative, our signs are positive and negative, because the only way we can multiply two numbers together and get a negative is if one of them is negative and the other is positive. Now our first term, our terms that will go here and here, are the factors of x squared, the numbers that multiply together to give us x squared, x and x. And what that leaves us with is the factors of 100. Now if I list all the factors out, we have 1 and 100, 2 and 50, 3 doesn't work, but 4, 25, 20, 6 doesn't work, because 6 only works if both 2 and 3 do. 7 doesn't work, and that is it. So now we need to see which set of terms would add or subtract from each, well, here would subtract from each other and give us 15. So that would be 5 and 20. 20 would be positive, and 5 would be negative, because 20 minus 5 is 15. Now, this is telling us that these two multiply together to give us 0, yes? What's the only number that we can multiply another number by and get 0? Yes? Because if we distribute this back out and we check it, so, well, this way, x times x is, x times negative 5 would be negative 5x. 20 times x would be plus 20x. And lastly, 20 times negative 5 is negative. And if we combine the middle terms, negative 5 plus 20 is going to be plus 15. So we're going to go into it here. It's not going to show up as much, especially on the homework, but it did show up here. Any other questions on this here? Okay. Now, we do have two things multiplied together. Yes? And they're equal to 0. Well, what is the only number I can multiply anything by and get 0? 0. Now, we actually do have a theorem that's called the zero product property, which states if we have two or more things multiplied together to equal 0, one of them must be 0. So what we can say is that x plus 20 is equal to 0 and x minus 5 is 0. Now if I solve the x plus 20, we would subtract 20 from both sides, telling us x is equal to negative 20. That's one of our two solutions. The other one we would add 5, telling us x is equal to 5. Any questions on how we found these two here? So if we look back at the problem, x is on the outside. It's the length of RS, yes? Is there one of these two values that won't work? Which one? Negative 20, because we can't have a length of, that is, negative. So RS is 5. Yes? Most likely here, yes. In some, it could be, for most of the ones that we'll do, there's going to be one that doesn't work. Questions on this here? Question on anything we've done so far? All right, let's look at another one. This one here is actually a little bit nicer than the one we just did. Now, again, our theorem states that we have the tangent length, in this case x being squared, is equal to what? The exterior of the segment times the whole segment. We can say is 12 plus 15. Or really, we have 12 times 27. Because we could have added those two together from the beginning and gotten this here. Now on the other side, x squared is the same as x squared. Yeah. Now at this point here, we do need to multiply 12 and 27. Is 324. We do take the square root of both sides, because the square root and the square will cancel, giving us x is equal to second square root 327 is 324, as I say, otherwise that would not have been a nice number, is x is equal to 18. We would normally put a plus or minus, because whenever we take the square root of both sides, we put the plus or minus. But if we notice back in the problem for this here, the length is just x. Length cannot be negative, distance cannot be negative, so we don't take the negative case into account. Any other questions on this here? We good with this one here? We ready for the next one? Now looking at this one here, we do have the tangent value as x, yes? So we would say the tangent length squared is equal to the exterior times the whole. Now we could put it as 3 plus 1, but we know that's actually going to be what? And our x squared, we can just rewrite as x squared. So x squared is equal to 4. And again, just like with the last one, because it's just x on the outside, we don't include the plus or minus. We just have the positive case. Questions on any of this here? These are a little bit nicer when we're finding the tangent length than the secant length, yes? We're ready for the next one, where we're dealing with finding the secant length. So let's set this one up. So the tangent length, so 7 squared is equal to what? The exterior 5 times the whole, which would be what? 5 plus x, x plus 5, either one. So are we good with setting this one up? Yes? Then we would indeed. Yes, we're good here. So 7 squared is? 5 times 5 is? Yep. So our 5 times 5, yeah. Yeah, that was unfortunate. Well, luckily it's not. Otherwise, a lot of stuff would fall apart if that were the case. So our 5 times 5 would give us 25. 5 times x is our 5x. Yes. Now we do need to get x by itself, so we would subtract 25 from both sides. Divide both sides by 5. X is indeed equal to 4.8. And that's it. Questions on any of this here? Now, look, most of the math problems try to, especially the ones we cover, try to give us nice numbers, but realistically, that's not always the case. And if we encounter real world problems where we're actually looking at this and applying it in a real world setting, the values that we actually find are most often normally very ugly decimals, because it just doesn't normally work out that we get a nice number unless we set it up or have it set to a way that would give us a nice number. Any questions on any of this here? We ready for the next one? So our exterior is okay. I think I did switch them because, again, this here, if we have x on the outside, we'll get another quadratic. It's a little bit harder. So we can switch it. I think, again, I just didn't switch the note sheet. Yeah, let's switch it this way. I'll need to remember to fix the note sheet. Now for us here, we'd have the tangent squared is equal to exterior times the whole. Now 12 squared is, on the other side we would distribute the 10. 10 times x is 10x. 10 times 10 is 100. Then we would subtract 100 from both sides, telling us that 10x is equal to. Then we would which is indeed 4.4. As a fraction, I believe that would be 22 over 5. Because 10 and 44 both have a common factor of 2. So 22 over 5, 4.4, either one will work. Questions on these here? You ready for the next one? Find the radius of the aquarium tank from this here. Exactly, we can say the tangent squared is equal to, what's the external? What is the whole? So we can say x or r, because we do have r, yes? So we have 2 of them. Because if we multiplied them, we would indeed have r squared. But here we're just adding them, adding the lengths together. So, yeah, so we could say this, or we could say 8, 2r plus 8. Now 20 squared is 400. Now we need to distribute the 8 here. 16r plus 64. Mm-hmm. You're good? Yes. Mm-hmm. So we're finding the radius. If we're finding the diameter, I could have just replaced the 2 r's with d. Because to get the whole length from d all the way to c, we have the radius twice. Because we're talking about the whole length. Mm-hmm. So what we're finding is the radius, because when we do get it plugged in, so we have it twice instead of just once. Because we need the whole length. Because the length of the secant's going from D to C. So if I did it once, just the radius once, I'd only get to the halfway point. I need R twice. Yes. Because the distance from here to here is 2 times R. So that's where we get R and R.
I get that. I see that, but I don't see how it's the radius. I feel like it's the diameter because it's going all the way across.
Right. Yeah. Right, and the diameter is twice the radius.
Well, why do they call it radius? Why couldn't they just call it diameter?
Well, we could, but then we would divide the value we get by 2 at the end.
I have a question.
Yes.
Can you just like can you just work one of the radius, and like subtract it from 8, and then that would be like both parts of the radius, right?
8's on the outside.
Oh, okay.
Mm-hmm. Now, because again, since we use 2r, it will actually give us the radius's value. If we put it in as the diameter, just d, we would get a value that would divide by 2.
I don't understand how if we're looking for the radius using two radiuses, how is that going to give us the radius?
Because
You can get the whole of the diameter, but then you can cut it in half, right?
well, because are we using r? Yep. So 2r, the radius is used twice to get the full length, yes? So am I defining it as a single length or as 2 lengths combined? So when I find the original value, because again, we're going to end up taking just the individual length, that's what we're finding is the length. We just put them, we have the radius. Mm-hmm. Yes.
We're going to have to divide it.
We won't have to do anything at the end because it will be the radius itself. Because we took that into account at the beginning. Because if, well, r is the radius for this, yes? And we're finding r. So we are finding the radius. Now, if I set, instead of saying it as r, as this length, I said the whole length was d. Well, d, the diameter is, so then we would have to find the radius from there. Mm-hmm. But since we're not using the fact that it's a single length, we're just using the r, we're going to find the radius in the end without doing anything else to it. Now, here we need to do 64. 336. And lastly, we need to divide both sides by. Mm-hmm. So the radius is 21. Yes.
So it's just like
little bit. Any questions on this here? Okay, now I'm going to go back. Now, yes. So 20 squared is equal to, so the exterior length is 8. Now I'm going to define this as, from here to here, as the diameter. So the whole length would be 8 plus the diameter of the circle. Because the inside line would be the diameter, the outside is 8, so the whole line is 8 plus the diameter. Now we'd still have 20 squared, which is 400. Here we would distribute the 8. 8 times 8 is 64, plus 8d. Now, at this point here, we would need to subtract 64 from both sides, telling us that 8d is equal to 336. Now we need to divide both sides by 8. Tells us that the diameter is. Now the diameter is 42, but as we know, the diameter is equal to 2 times the radius. So we have to divide 42 by 2, telling us the radius is 20. Yeah, it messes with us. Yes. I think a little bit having r plus r, because we're so used to seeing it as 2r for the whole length, not just r plus r. Does that kind of make sense? Any other questions on this here? And that is it.